Hi everyone, welcome to Vedantu NEET English. I'm Diksha, your chemistry master teacher. How are you all? Firstly, I'm so sorry for being late. I'm so sorry for that. My system got into updation, so for that I was not able to operate this display screen. So that's why I am a bit late. Okay. Okay, so very good evening everyone. How are you all? I hope you all are fine and you have practiced your all the electron displacement effect. Have you? Because in today's lecture, we are going to do stability of intermediates and acidic and basic. For this particular lecture, you need to understand a few things like GOC, common basic things. And from this particular topic, 4 to 5 questions will be asked. Okay, 4 to 5 questions. 3 to 4 is like final. They will ask 3 to 4 questions from this topic, whether directly or indirectly. 3 to 4 questions will be asked for what we are going to do today. It's a very, very important lecture. But for this particular lecture, firstly we have to do. Am I audible to everyone? Okay. So firstly, you have to do aromaticity, back bonding, all these things, right? Only after that you can understand the stability of intermediates, right? Okay. Series still get 120 start. Oh yes, bacha, you can definitely follow the series. You will definitely get your marks if you are consistent and disciplined. Okay. Okay, so shall we start without wasting any time? Let us start the lecture. Okay. So in this lecture, everything will be on the basis of BARHA. You can also see the PYQs. In PYQs, all the questions are based on this particular statement, that is BARHI. Barhi. Okay, it's like bar high. Okay, barhi. So, beta, what is barhi? So, barhi is, first thing is back bonding. This is actually the priority order, right? This is a priority order of all the effects. So first priority is given to back bonding. Then there is aromaticity. Then we have resonance. Then after that, beta, we have resonance. Then we have hyperconjugation. And last is inductive effect. If you're not doing this particular topic, then I am telling you organic is not an easy task for you. But if you are able to understand this lecture, you know GOC, most of the questions, even from reactions, you will be able to understand and you will be able to give those answers only because you know what do you mean by stability of intermediates, right? So that is why I'm saying this lecture is the most important lecture till now, most important lecture, and from this lecture only you are going to get your marks, right? Okay, perfect. So let us start. First question is this. Okay, we'll start practicing not only do the theory part, we'll learn from practicing the questions. So these are the questions. So first is this. Bacha, this question. Are you able to see this? Just give me a minute. Okay. Yes. Okay. So how many students here are interested in giving the answers, right? So, bacha, if you really want to polish your organic chemistry, for that you need to give the answers. Only by listening or just cramming organic chemistry is not a thing that you need to cram. You just firstly need to understand the concepts, and after that do the practice. Only then you have a strong hold over organic chemistry, otherwise it's not possible. Okay, so kindly give the answers also. Right, give the answers also. Why the other students here are not giving the answers? Right, but it's not possible if you're not giving the answers. And for that part, that will not be possible. Okay. Whether the answer is right or wrong doesn't matter. Just use your brain and do something. Okay, what is the priority order? Answer this. The answer may get wrong, and after that, see what you have done wrong in that question and correct that. Okay, so first is A part, B part, C part. Now we have the order is BARHI. So can you see any back bonding here? There are vacant p orbitals, but there is no electron rich orbital. Okay, so that means no back bonding is happening here. Okay, so then we have aromaticity. Aromaticity, for that you need to have a cyclic ring, complete conjugation, nothing is here. Okay, so no aromaticity. For resonance also the condition are not fulfilled, so this is also crossed. For hyperconjugation, you have this positive. That means you have carbocation. Then now for hyperconjugation, see what are the alpha carbons. These are the alpha carbons here, and these have three. This have three hydrogen. This has three hydrogen, and this has three hydrogen. This has two hydrogens. So total is 3, 4, 5, 6, 7, 8 hydrogens. Right? And here you have, this is the alpha, this is the alpha. Now here we have one hydrogen, and here we have three hydrogens. So total 4 alpha hydrogen. And in this case, you have just this alpha carbon, and this alpha carbon has just 2 hydrogens. So you have 2 alpha hydrogen. For that case, you know these has A part has a maximum number of alpha hydrogen. That means it has a maximum stability. Now this question, we have answered this question not on the basis of inductive effect, because hyperconjugation is applied here, right? So that is why the answer will be A, then B, then C. The priority order will always be first is C, back bonding, then aromaticity, then resonance, then hyperconjugation, and if hyperconjugation is not there, only then jump to inductive effect. Okay, perfect. Perfect. Very good evening, bachcho. Very good evening. Hi. Okay, so Baswa sir is here. So let us now next is, this is A part, this is B part. So firstly answer this question. Now, as according to firstly let us see, is there any back bonding happening here? You have this vacant p orbital. And for this vacant p orbital, you need to have one any atom that is electron rich. So this oxygen atom has lone pairs, right? But this sulfur atom does not have lone pairs, so back bonding is okay. This also has lone pairs. So where the back bonding will be strong? Let us see. Here also, these two parts are interconnected to each other. So let us see. Here also, you have nitrogen and you have oxygen. So always remember one thing. When you are going from a period, when you are going left to right in a period, then there you will see the back bonding on the basis of electronegativity. Okay. So the concept here is that when you are moving in a period and when we are moving down the group, along the period you will focus on the electronegativity of that atom, and down the group you will focus on the size of that atom. Okay, down the group electronegativity will not be focused here, right? Okay, so now let us see, this is A and this is B. So let us understand why I have written it like this. Here also you have back bonding in both the cases. But because you know the electronegativity order is like this. So electronegativity order is like this. So for that oxygen is more electronegative. As oxygen is more electronegative, that means it won't be able to give the electrons as efficiently as nitrogen is giving. So here will be more back bonding. So the answer is A is more stable than B. This is along the period. That's why we are focusing on the electronegativity order. This is down the group. We have O, this. Okay. The group is oxygen, sulfur, selenium, then tellurium, then. Okay. Perfect. Now, what will be the answer down the group? We do not focus on the electronegativity. Focus on the orbitals. As we know, overlapping. Okay. Here we are going to focus on the overlapping. So, if we are talking about a carbon atom and we are talking about an oxygen atom, and here we are talking about a carbon atom and here we are talking about a sulfur atom. Carbon and oxygen are these belong to the same period, right? So that means here also 2p overlapping will be there, and here you will have 2p, 3p overlapping. As you know, the overlapping between the same kind of orbital is more. So 2p overlapping is stronger than 2p overlapping is stronger than 2p 3p overlapping. So that is why That is why here the overlapping is much more as compared to this. So that is why A is more strong. A is more stable than B. Understood? Understood? There are two things that you need to focus when you have questions like this. Back bonding is happening in both the cases, right? This is down the group and this is along the period. Along the period, just focus on the electronegativity, right? And down the group, focus on the overlapping of orbitals. Understood, everyone? Okay? Perfect. Okay, every question you need to just apply this thing. Now, next is, this is A, this is B, and this is C. These three things. So now this case, yes, in this case, what we are going to do, you have these three things. In this case, you have a carbocation, right? You have a carbocation, and here you have this carbocation, right? The order is BARHI. So now, for back bonding, we are talking about, is there any concept where back bonding is occurring? Any A, B, C part where back bonding is present? Back bonding is present in this case. There is orbital, vacant p orbital, and there are lone pair of electrons on nitrogen. So back bonding is present here. Here is back bonding. So whenever back bonding is present, it is the most dominating factor of stability. Back bonding is the most dominating factor. So you will write A is most stable. In B and C, you don't see any back bonding here. In B and C, you don't see any back bonding. Do you see aromaticity? No, we don't see any aromaticity here. Do you see resonance? No resonance here. So now, if we see hyperconjugation, this is alpha, this is alpha, this is alpha, this is alpha. Even the hyperconjugation structure are also same. That means hyperconjugation is not here present. So now, the factor here is inductive effect. The factor here is inductive effect. Inductive effect means now this nitrogen is electronegative. If it is electronegative, that means it will withdraw the electrons from this carbon. It is already positive and we are taking away the electrons from it, making it more unstable. And this is more closer as compared to B. In C, nitrogen is more closer to the positive charge as compared to B. That means in C part, it will be able to extract the electrons more efficiently, making it more unstable. Right? So as compared to B and C, B will be more stable as compared to C because here the difference is more and here the difference between this nitrogen and this vacant p orbital is less. Right? So the order is A, then B, then C. Understood, everyone? Understood, everyone? Perfect. Perfect. Okay. Okay. Why there are so less students here? Huh? Don't you share this with your friends? Huh? Very confused. You don't share this with your friends because you don't want anyone to see the lectures. Hai? That is wrong. That is not right. That is not right. In next class, I want at least 50 students present here. Okay? I want at least 50 students present here because otherwise it's very boring. It becomes very boring in that kind of class. Right? Okay. No, there are so many. There are so many questions. Don't worry about the question. A lot of questions present. Okay. So now this is A, this is B. Here also we see BARHI. No, please, one more. Do you want more examples or are you not able to understand this? More examples or this is clear to you? This is clear to you? Because of back bonding, this is more stable. And in B and C, you have inductive effect. Here, inductive effect is according to the distance. So here, the distance is more. That is why minus I effect is less. And minus I effect is making it unstable. And here, because it is more distance, so minus I effect, more distance between this nitrogen and this vacant p orbital is making it more stable as compared to C. So the order is A, B, and C. Okay? Yes. Okay. Then next we have BARHI. Now, here also, can you see any back bonding here? Can you see any back bonding here? Yes, you can see because these halogen atoms have lone pairs on it, right? And this is a vacant p orbital. Now, here back bonding is present, but ma'am, in both these cases, back bonding is present. Which thing should be so? So now here this is fluorine, chlorine, bromine, iodine. That means it is down the group. And down the group you see the overlapping of orbitals. And this is 2p and this is also 2p. The overlapping will be stronger. This is 2p. This is 3p. The overlapping will not be that much stronger. So simply the concept is here the more back bonding, that means it is more stable. So the answer is A is more stable than D. Understood? A is more stable than D. Right? Okay. Now Shelha, have you understood the last concept? Have you understood the last concept? Right? Here, along the period, just see the electronegativity difference. Right? But down the group, see the overlapping. Right? The atoms that belong to the same period have good overlapping as compared to those that belong to different periods. Right? Okay. Perfect. Now next is this part. This is A, this is B, and this is C. Let us see how do we calculate which is more stable here. Only thing that you need to remember is BARHI. Only thing that you need to remember is BARHI. Okay? So for this, just see, firstly you have back bonding. Do you see any back bonding here? There are vacant p orbital, but there is nothing that is providing them electrons, right? So no back bonding is present here. Can you see any aromaticity? No cyclicity, no aromaticity. No resonance is present here. Hyperconjugation structure. I can't see any hyperconjugation structure. Only here I can see hyperconjugation structure. I can't distinguish them on the basis of hyperconjugation structure. Then there comes inductive effect. Now, ma'am, how do we define the inductive effect here? So see, this carbon has 3,4 sigma bonds. That means this is sp, 3 hybridized. As you all know, if you have lone pair plus sigma equals to 4, then 3, then 2. If it is corresponding to 4, we have sp3. Corresponding to 3, we have sp2. Corresponding to 2, we have sp. Right? So this is having 4 sigma bonds. That means sp3. This is having 2 plus 3 sigma bonds. No lone pair here. That means 3 corresponding to sp2 hybridization. This is having only 2 sigma bonds. That means this is having sp hybridization. Right? As you all know, the hybridization is sp, sp2, sp3. And what is the electron? The more is the s character, the more is the electronegativity. Here the s character is more. So electronegativity order is sp, then sp2, then we have sp3. Okay. So this is positive, this is positive, this is positive. This is sp. So it is able, it has, the more is the electronegativity, the more is the minus side effect. So this is also the order of minus side effect. The order of minus side effect. So this is able to pull the electrons towards itself more efficiently as compared to sp2 and as compared to sp3. So the more it extracts the electron, pulls the electrons from the p orbital, it is already electron deficient and you are pulling the electrons. That means you are making it unstable. So this is the most unstable, this is less, and this is the most stable. Why? Because it has least minus I effect as compared to sp and sp2, and that is the reason it is making it more stable as compared to this, because it is making this unstable because of its minus I effect. Right? So the answer is A, then B, then C. Understood everyone? Okay, bacha, understood everyone? All the students down in the comment section. Have you understood? Yeah. They don't share this with their friends. I don't know. The reason is because they are very jealous. They don't want to share this with anyone because they feel that we don't want any competition, ma'am. But bacha, you need to know the competition, right? You need to sit in a class where there are so many students present and you know what they are learning, right? Where you are in comparison to them. So share this with your friends and also make me feel happy. Okay, don't make me feel sad. Right? Okay. Yes. Okay, so this is A, this is B. We teachers do lots of hard work for you, and if you're doing conjugacy in liking the session, commenting the session, and sharing the session, then you're doing bad on your part. Then I am not happy with you all. Okay, we just demand one thing, that is just write your queries in the session, and if you like this, only if you're attending this session, that means you like this session, right? And if you like the session, then also share this with your friends so that even I can feel motivated. Okay, there are students who are coming and who are feeling motivated and who are actually understanding this session, and that is why they are sharing this with their friends. So I just need that one thing. If you're not doing that, then that is wrong. Okay. And then jump to 12th organic. Yes, perfect. Yes. Firstly, we need to complete the GUC section. So this is A, B, and C. Here also apply the BARHI rule here. Firstly, you have back bonding. Here, can you see back bonding here? No, we cannot see back bonding. Vacant d orbital, but no electron-rich atom to provide the electrons to vacant p orbital, right? So no back bonding. No aromaticity. Can you see the aromaticity? Oh, ma'am, we can see the aromaticity in C part. Ma'am, we can see the aromaticity in C part. Tell me if this is aromatic or anti-aromatic. This is PCC. This is following PCC. It has 4 pi electrons. That means this is anti-aromatic. And as I told you, anti-aromatic is the most unstable species. No compounds want to react and get into anti-aromatics. That is why this is the most unstable out of A and B. Right? Okay. So now you have this A and this B. Now let us see which effect to apply here. Here you can see resonance. Right? Here you can see resonance. You can see a conjugation here. Right? So that means this factor is also applied here. And here you cannot see resonance. So resonance is more stable. Resonance makes the structure more stable as compared to where there is no resonance. So that means this is more stable than B. So this accounts for A, then B, then C. Understood everyone? Understood everyone? Okay, bacha. Chat box with heart to our Diksha ma'am students. Thank you. Yes. So many less hearts. Why so? Why are you not able to give your heart to me? You can give your heart to anyone, but not your teachers. Teachers will take care of your heart. Do you know that? Teachers will take care of your heart more than anyone else. After your parents, teachers can, take care of your heart. Yes. Perfect. Okay, so now let us do the next question here, A, B, C, D. Now tell me which is the most stable and apply here BARHI. Apply BARHI on this. Right? Okay. Wow, so many green hearts. Please, the order of BARHI. Yes. The order is BARHI, back bonding, aromaticity, then resonance, then hyperconjugation, then inductive effect. Okay. Which color for me? First here, sir, which color you have? You have pink color? Give him pink hearts. Okay. Very nice. Pink hearts, purple hearts. Very nice. Sir, choose white. Heart for Didi, Gopika ma'am, Shreya sir. Arey, you forgot Baswa sir. For also Baswa sir. Yes. So now you have this A, B, C, D. Now in this question, let us see if there is any back bonding present here. There is no back bonding as such. You have this orbital and there is no back bonding present here. What about the aromaticity? Can you see any aromaticity here? Here you have this aromaticity present here. But there is no differentiation on the basis of aromaticity. So this is also cut. Now next is resonance. When resonance is happening here also. In A, B, C, you have resonance. But what about the differentiating factor on the basis of resonance? We can't differentiate on the basis of resonance. But what we can do, that is one thing. Okay, as we all know, when you have this thing, when you have now, everyone in the chat box, tell me if you have a vacant p orbital. Very nice, bachcho, very nice, very nice. Perfect. Also, let us see how many students have liked this session. Yes. Okay, perfect. So now you have, this is the structure that you have. As you know, this is actually, this CH2 positive, this takes away the electron as according to minus M effect. By minus M effect, you know, through minus M effect, it gives ortho and para positive charge, right? Because of minus I effect, you have ortho, you have positive charge on ortho and para position. This is ortho, this is meta, and this is para position. So now, as you know, this ortho and para will have positive in all these cases. In all these cases, ortho and para will have positive. In all these cases, ortho and para will have positive charge, right? So now, this is the use of resonance here, right? This is the use of resonance here. Resonance means now you have positive charge on para position. Positive charge on para position means this positive charge is actually delocalized on this ring. This is also on the ortho position and also on the para position. That means here there will be, this is positive charge and this is CH3 present here. Now this will be a question. Now the question will be converted to this part. Now you need to focus on just this part. Just this part, right? This is your main question now. This positive charge is actually distributed in the ring on the ortho and para position, and that is why the main focus here is this part, this part, this part, and this part. And in these four parts, you can apply hyperconjugation, isn't it? You have carbocation, and this is the alpha carbon, this is the alpha carbon, this is the alpha carbon, and this is the alpha carbon. This alpha carbon has 3 hydrogen. This alpha carbon, this is also alpha carbon. But we need to see the alpha carbon, that is sp3 hybridized, right? So this is sp3 hybridized as alpha carbon. This is alpha carbon. This alpha carbon has 2 hydrogen. This alpha carbon has only 1 hydrogen, isn't it? This has only 1 hydrogen. And this has no hydrogen because all the tetravalency of carbon is completed here. So it has just 1 hydrogen, 2 hydrogen present here. This has 0 hydrogen actually. This has 1 hydrogen, right? So the number of alpha hydrogen contributes to the stability of that carbocation according to the hyperconjugation structures. The more the alpha hydrogen, more is the hyperconjugating structure and more is the stability. So here we have applied 2 things, that is resonance and hyperconjugation. Because of resonance, because of the minus effect of this CH2 positive, we have ortho and para positive charge on ortho and para position. And because of that thing, we are able to understand that here the hyperconjugation will be the factor. So the answer will be A, then B, then C, then D. And these kind of questions will be asked in the exam. I'm 100% sure these kind of questions will be asked in the exam. So if you're totally ignoring these things and focusing on the cramming the reactions of organic chemistry, there is no use of doing that. There is generally no use of doing that. Okay, if you're focusing on organic chemistry, you can easily secure your 20 marks. And 15 to 20 marks you can score. If you are doing general organic chemistry, including isomerism and IUPAC naming. Right? Okay. Very nice. So now, this is the next question. This is A, this is B, this is C, this is D. Everyone in the chat box, tell me what will be the stability order as according to BARHI. As according to Barhi. According to Barhi, what is the stability order here? What is the stability order here according to Barhi? According to Barhi, what is the stability order here? Everyone in the chat section. Everyone in the chat section. How do we solve this question? Can we see any back bonding here? Can we see any back bonding? No. Ma'am, we cannot see any back bonding. Aromaticity, we can't differentiate on the basis of aromaticity. Resonance, ma'am, as the positive charge is on this particular carbon, so according to minus I effect, minus M effect of this, okay, minus M effect means minus of mesomeric effect, right? It will pull the electrons from the ring and it will create a partial positive charge on ortho and para position, ortho and para position, ortho and para position, ortho and para position. So now what you see? Ma'am, but we have positive charge on the ortho and para position. So there is no use of this positive charge here, right? We can't apply hyperconjugation here, right? For hyperconjugation, the positive charge, the alpha carbon, the number of hydrogen on alpha carbon defines the stability as according to hyperconjugation. But here, the alpha carbon is this, we can't define the stability here, right? This alpha carbon is sp2 hybridized, here also alpha carbon is sp2, here also alpha carbon is sp2, here also alpha carbon is sp2. So hyperconjugation will not be the factor here. What will be the factor then? What will be the factor? The factor will be inductive effect. The factor will be inductive effect. As you all know, we have just one methyl group that is giving the electrons, that has plus I effect, right? And this is ethyl. Ethyl has the plus I effect more than that, right? Okay, it will also give the electrons. It will also, this we have two CH3 groups and it will also give the electrons. Here we have three CH3 groups, it will also give the electrons. So we all know the plus I order. The plus I order is like this. CH3, okay, this is CH2, CH3. This is 2CH3 and this is 3CH3. 3CH3. Because of three methyl groups, the plus I order will be maximum here, then here, then here. Right? And this is just one carbon. These are two carbons. So this, in this case, the plus I order will be more as compared to CH3. So more the donation of electrons, if one thing is positive and we are donating the electrons, more the donation of electrons, more will be the stability. If something is electron deficient and we are providing the electrons, that means we are providing the electrons, we are making it more stable, and that is the reason this will be the more stable and the stability order will be BCBA. See how things change when you have put the same thing, the same group on para position and the same group on meta position. Things have changed like this. What is the reason behind that? The reason is this priority order. Here the hyperconjugation is not applied. Here the inductive effect is applied. Inductive effect of methyl groups is applied. Understood everyone? Understood everyone? Here the inductive effect is applied. When? Because we don't have any positive charge on the meta position. So no hyperconjugation, right? The alpha carbons are sp2 hybridized. We can't answer this question on the basis of hyperconjugation. Plus I effect will be the deciding factor here. Right? Okay? Understood? Perfect. So now let us move to next question. This is A, this is B, and this is C. Tell me what is the order? This is A, this is B, and this is C. What is the order? This is positive, right? This is positive, this is positive. And ma'am, we know that from resonance, see, BARHI, understand one thing. Something like this means this positive charge is in resonance. And because of minus M effect, the positive charge will also be on ortho and para position. And ortho and para position, the positive charge will distribute to ortho and para position because of minus M effect. because of minus mesomeric effect. Understood? Now you can clearly see, ma'am, earlier we were not able to see any back bonding, but now can we say back bonding is present in all these structures? Everyone in the chat box, can we say back bonding is present in all these structures? Right? Right? Do you agree with me that back bonding is present here? Back bonding is present here. Back bonding is also present here. All these atoms have lone pairs of electron. They are electron rich and they will give the electron to this vacant p orbital. Right? Okay. So now what will happen here? What will happen here? Just understand this thing. What will happen here? Now, bacha, this belongs to just one thing. We have three things. This is N, this is O, and this is Cl. We know Cl doesn't belong to the same period as O and N, right? So these two will be decided on the basis of electronegativity. On the basis of electronegativity, right? Okay, and the among this and this have 3p orbital and carbon have 2p orbital. And this will be decided on the basis of overlapping. Overlapping. And this does not belong to the same period as carbon. So the overlapping of orbitals, if you are giving something to someone, you need to be in the same house. That way it is easy. Otherwise, you have to courier something. If the person is available to you face to face, then it will be easy for you to deliver something as compared to when you have to courier something, right? Okay, so in this case, they are not living in the same house, they are not living in the same city. This is living in 2p, this is 3p. So the overlapping will not be good. Here, this is also belong to 2p and this is also 2p. The overlapping will be good. But the difference here will be electronegativity. We know FON. Oxygen is more electronegative. That means oxygen will not be able to give away its electrons as compared to nitrogen. Nitrogen is little bit sweet, just like you guys, very sweet. He is able to give the electrons. He can easily give the electrons. He is a very innocent person as compared to oxygen. Oxygen is very clever. He don't want to give its electron. He don't want to back bond with anyone, right? So that is why here the back bonding is stronger as compared to B. Here also you have 2p. Here also you have 2p. Right? But in this case, you have 2p, 3p. So overlapping will be very weak and this will not have a very good back bonding. So order is A, then B, then C. Understood everyone? Understood everyone? Tell me. Have you understood this concept? Very, very important. You have applied so many concepts here. You have applied back bonding concept here. You have applied along the group. You have applied around the period, down the group. Everything here. Back bonding was also not visible to you directly. Through resonance, you know where there is back bonding or not. If that was in meta position, there will be no back bonding. In case this NH2 will be present on meta position, there will be no back bonding then, right? Then there will be minus side effect. Understood? Understood everyone? Very nice. Yes. Next is this question and answer this question. Answer this question everyone. It's a very simple direct question. Very simple and very direct question. Very simple and very direct question. Everyone in the chat box, answer this question. Very simple and very direct. What is the answer? What is the answer, everyone? Yes, what is the answer? Here you have 2 carbons. Here you have 3 carbons. So, as compared to 2 carbons, 3 carbons have more plus side effect. It has more plus side effect. Right? This is positive. The plus side effect is more. Right, so this will make this more stable. So this has more plus side effect. This also has plus side effect, but plus side effect of propyl is more than ethyl. Plus side effect of propyl is more than plus side effect of ethyl. That means this is giving the electrons this positive charge, making it more stable. So that means B is more stable than A. B is more stable, bacha. B is more stable. Right? B, no. B is more stable. This carbon is also, like we said, CH3 has the less plus effect as compared to CH3, CH2. Why? Because in these kind of matters, we say that propyl more the number of carbon atoms, each carbon atom and hydrogen will have its plus effect, right? And together they will contribute more towards the giving the electrons. We have 3 carbon atoms, right? Okay, here we have just 2 carbon atoms. Understood? Yes, B is more than A. Yes. Now, this is the next question. Next question. Answer this. Everyone. This is a very nice question. Answer this, everyone. Very nice question. Answer this. What will be the correct answer to this? What will be the correct answer? Everyone in the chat box. What will be the correct answer? What will be the correct answer? You have this positive charge here. You have BARHI, right? BARHI. There is no back bonding present here. We can see no back bonding is present here, right? Nothing adjacent to this vacant p orbital, so no back bonding. Another we have aromaticity. Can we see aromaticity here? No aromaticity, ma'am. Can we see resonance here? No resonance here. Can we see hyperconjugation? Both have same alpha carbon, so no hyperconjugation here. Hyperconjugation is present, but we cannot differentiate on the basis of hyperconjugation. So let us see the inductive effect. The distance is same between the two groups. It has 3 methyl group. That means it is having 3 times plus effect. It is giving the electrons to this positive charge, to this electron deficient p orbital, right? Vacant p orbital. And this is NO2 group. And this has minus effect. This is very electronegative, right? So it will take away the electrons. This is already positive. You're taking away the electron. That means you are making it more unstable. So A is more stable than B. A is more stable than B. Okay? Very good. Here only we applied inductive effect, nothing else. No combination, nothing, just inductive effect is applied here. Now, answer to this question. Wait a minute, there was something wrong with this question. Just wait a minute, everyone. Everyone, just give me a minute. There was something wrong with this question. Okay. It was like this. Okay. Now tell me now, which is more stable, which is less stable? This is BARHI. Back bonding in A or B. Can you see back bonding in A or B? In which A or B you can see the back bonding? Everyone in the chat box, can you see back bonding here? Can you see back bonding here? Yes, they got it. In A, you can see back bonding. Can you see back bonding in A and in B? In B, we can see the back bonding directly because this oxygen is attached to this vacant p orbital. So here back bonding is happening. Here back bonding is present. Right? So we will say back bonding is present here. But in this case, we can directly see the back bonding. If we draw the resonating structure, this will be what this will be. Okay, if we draw the resonating structure, this double bond will jump here, right? Double bond, single bond, then vacant p orbital, right? So this double bond will jump here, and here will be positive charge, and now you can clearly see the back bonding present in this structure as well. Okay, you have this A structure and this B structure. But in A structure, you have back bonding plus resonance. In B structure, you have just back bonding. That means A is more stable because here we have two factors. In this case, we have just one factor. Here we have back bonding plus resonance, and in this case, you have only back bonding. That means A is more stable than B. That means A is more stable than B. Understood, everyone? Okay. Okay. So now let us jump to another, that is A, this is B, and this is C. These are the isotopes. These are the isotopes. So more is the mass, more is the plus effect. More is the mass, more is the plus effect. Right? More is the mass, more is the plus effect. That means the plus effect order is T, D, then H. This is the order of plus effect. Now, if we see this clearly, this is positive charge. And this has 3 tritium ion attached to it. That means it has maximum plus effect as compared to B, as compared to C. So that means here A is more stable than B, then C. Because of plus effect order is this, that is T, D, H. Understood, everyone? The plus effect order is T, D, H. It has 2 lone pairs, but it has 2 lone pairs. Yeah, it has 2 lone pairs. Okay. Now, let us do this. This is A, this is B, and this is C. Everyone in the chat box, answer this question. Wow, amazing question. Now you have this carbocation and you have 3 groups further attached to it, right? Okay, so according to BARHI, there is no back bonding here. No aromaticity, no resonance. Let us talk about the hyperconjugation structures here, right? Let us talk about the hyperconjugation structures. You will say, ma'am, hyperconjugation is there, but it will also have 9 hyperconjugation structures. It will also have 9 hyperconjugation structures. It will also have 9 hyperconjugation structures. So what is the difference? The difference is that hyperconjugation structure is because this CT bond, this CD bond, this CH bond will break and it will form a hyperconjugation structure. So more easily C and this particular T or D or H bond is broken, the more easily will be the hyperconjugation structure. So what is the bond strength of these 3 lengths? What is the bond strength? What is the bond strength? So here, the bond strength order is, the bond strength, I am talking about strength. The bond strength order is CT, then you have CD, then you have CH. This is the bond strength. This is the bond strength order. Now, if you have to break the bond, which bond will be broken most easily? That is the CH bond is most easy to break. That means CH bond, the hyperconjugation structures involving the breakage of CH bond will be, the hyperconjugation structure will be formed the fastest, right? Okay, so in this case C is more stable than B, then B. Understood, everyone? The bond strength order is this. The bond strength order is CT, then CD, then CH. That means that the CT bond will be very difficult to break and hence the hyperconjugation structures will be difficult to form. And CH is easy to break, so hyperconjugation structure is very easy to form. And that is why CH is the most stable. This is the number of hyperconjugation structures are same, but the stability is different because of the bond strength of CT, CD and CH. Understood, everyone? Everyone in the chat box, have you understood or not? Everyone in the chat box, have you understood or not, bacha? Tell me, have you understood or not? Now you have next question, and I expect that you will answer this question. I expect this from you, that you will answer this question. Okay? Yes. Very nice. Very nice. I expect all of you to answer this question. As you all know, we have already done this question. We have already done this. Okay? This is also, we have already done this part as well. Right? So what is the correct order? What is the correct order? Everyone, what is the correct order? Yes. Okay, let us apply BARHI. Everyone in the chat box, everyone in the chat box, write BARHI. Everyone in the chat box, write BARHI. How you will define the order? The simple way is BARHI. Back bonding, aromaticity, resonance, hyperconjugation, inductive effect. One by one, see which factor is applied here. And according to priority, only answer this question. Okay, so firstly, can you see back bonding here? Everyone in the chat box, write BARHI. Write BARHI. Everyone in the chat box. Only Nancy. Very good, SK. Nancy, SK. Everyone. See, I have made this very easy for you, right? You just need to remember one thing. If any question based on stability of intermediates, just remember one thing. Okay, ma'am, this is bari. Okay, see? Very nice, very nice. So, bacha, if we talk about back bonding, can you see back bonding here? We cannot see any back bonding here. Can you see aromaticity here? No, ma'am, no aromaticity is here. Can you see resonance here? Can you see resonance here? Ma'am, here we can see resonance. Here we can see resonance. Right? This is showing resonance. That means this is making this ring more stable. Resonance means more stability. Right? Resonance means more stability. It will show minus M effect, and it will take away the electrons from this ring by minus M effect. Right, by minus M effect. Okay, so A will be more stable as compared to BCD. So now about BCD, what is the factor that is applied here? What is the factor that is applied here? Bacha, let us see. Very easy. As you know, it has just 1, 2. This is SP. This is 1, 2, 3. This is SP2. This is 1, 2, 3, 4. This is SP3. This has maximum minus effect. So it will make the structure most unstable as compared to SP2, as compared to SP3. So the order will be A is more stable, then D, then C, then B. This is the correct order. Very nice. The order is A, D, C, B. Everyone, are you able to understand? The order will be A, D, C, B. The order will be A, then D, then C, then B. Okay? Yes. Next is this question. Bacha, is there any problem till now? Is there any problem till now? Any problem till now? Any problem to any student? Any student? Any problem till now? All the concepts are getting clear or not? Because I am telling you, short, if you are taking this lecture, you are, securing your 15 to 20 marks. Okay? Perfect. Now, this is A, this is B. It has BARHI. You can't see back bonding, you can't see aromaticity. But you can see resonance in this structure. You can see resonance in this structure. This is nothing but like this. This is nothing but this. You can see resonance here. Here we have minus M effect. Minus M effect. Here there is resonance present. That means this is more stable. And here you can see the plus side effect of 3. Now tell me, what is the order? Tell me what is the order. Miss I is the more stable order. Miss I1 more stable order. Yes. I1 more stable order means what? Can you please elaborate that? Which is more stable here? B is more stable, B is more stable. Everyone is saying this here, right? But if I tell you A is more stable here, A is more stable here, here we have exception. A is more stable than B. What is the reason behind that? What is the reason? Yes. The I order is SP. Okay, the I order. Okay, let me tell you here. Bacha, the I order is, the minus I order is SP, then SP2, then you have SP2. And what is the reason? What is the reason? If you're asking this, let me tell you the reason. SP2, this is SP3, right? This is 50% S character. It has 33.3% S character. It has 25% S character, right? And more is the minus I effect is directly proportional to electronegativity. More is the electronegativity, the tendency to pull the shared pair of electron toward itself. More is the minus I effect, and this is dependent upon the S character. And that is why the order of minus I effect is SP, then SP2, then you have SP3. Right? Okay? Perfect. So now, what is this exception here? What is this exception here? No methanol is here. Okay? What is this exception here? See, here we have 3 methyl groups giving plus I effect. So, in this case, the effect of the inductive effect as compared to the resonance effect of one phenyl group, the inductive effect of 3 methyl groups wins over the resonance effect of just one phenyl group. And that is why in this case only inductive effect makes it more stable as compared to resonance, because the amount of inductive effect is much more than the resonance effect. Okay? Yeah. I hope so. After this, you will not forget about this question. This is an exception. This is an exception. Understood, everyone? Yes, perfect. Now, you have dancing resonance. This is like the most favorite resonance of all the students here. Right? Why so? Because this resonance is actually dancing on one leg. Okay, why I'm saying it is dancing on one leg? And this is the most stable. Whenever you see dancing resonance, dancing means when you dance, you are very happy, right? So when you are happy, you're in a very stable state. So this is dancing resonance. It's very happy. So it is dancing and it is in the most stable state. So it is even more stable than back bonding. As compared to back bonding also, this resonance is more stable, right? So what is this? You have this 3-membered ring, right? So this 3-membered ring, you have the orbitals here like this. You have this orbital here, the orbital here, the orbital here, the orbital here, the orbital here. So because of this overlapping of orbitals and the space is very less, because of this, they develop a strain. They develop a angle strain here, right? That is very difficult. So now what they do, one of the sigma bond is broken down, right? So what happens actually here, this bond will be broken down and the electrons will jump here. So what will be the resonance here? It will dance on one leg. This is one leg, it is dancing on one leg, and the positive charge will be here because these electrons had jumped to this side. So this is now electron deficient, and here will be double bond and this will be CH2, right? This can also happen like this. This can also happen like this. If this particular bond is broken down, so it will also dance on the another leg. So this is the another leg. It is dancing in the party, and that's why it is the most stable resonance of all. Most stable. Okay. Dancing resonance is more stable than the all the things that we have discussed till now. Okay? It is more stable, all the things that we have discussed till now. So now this is A and this is B. Answer this question. This is A and this is B. What is the correct answer? This is A and this is B. You have this negative charge, you have this negative charge. Here we are talking about the stability of carbanions. We are talking about the stability of carbanions, right? The stability of carbanions. So let us see, this is negative, this is sulfur, this is negative, this is oxygen. Here also back bonding will occur, right? But the factor here will be negative. If this is negative, this is electron rich. It needs some vacant orbitals. It needs some vacant orbitals on the adjacent position so as to donate the electrons to this vacant orbitals, and hence back bonding will occur in this case, right? So tell me, do sulfur have vacant orbitals or oxygen have vacant orbitals? From inorganic, you all know that oxygen do not have vacant orbitals, but sulfur have vacant d orbitals. So that means here the back bonding will occur. So this A is more stable than B because of, here I am writing, because of vacant orbitals of B, of sulfur, right? So the back bonding is the factor here. Back bonding is the deciding factor in this case. Yes. Okay? Yes. Most of the students, you know what they answer here? What, you know what most of the answer this? B is more stable than A. Because they think that this is more electronegative, so it will pull the electron towards itself, and this will not pull the electron, so the back bonding will occur here. But this is not the same. Here the back bonding is the main deciding factor, and for back bonding you must have vacant orbitals, and among this sulfur and oxygen you have vacant orbital in sulfur. Okay, so the answer is A is more stable than B. Now you have another, this is A, this is B, and this is C. Tell me, bacha, which is the most stable? What is the order of stability here? What is the order of stability here? Now you have, let us see, back bonding is present anywhere? No, we can't see back bonding, ma'am. Can we see aromaticity? Oh, ma'am, we can see here the PCC order is followed. That means it has 1, 2, 3, 4, 5, 6 electrons. So that means it is aromatic. It is aromatic, right? And aromatic is the most stable, right? So this will be the most stable among B and C. Here we can't see any aromaticity, right? So aromaticity we have decided. Now among resonance, you can see, here we can see resonance. This is double bond, single bond and negative charge. And here we cannot see any resonance. So that means this is more stable than C. So the answer is A, B and C. Okay, aromaticity, resonance and then no resonance. Very good, very nice. Now next is, this is A, this is B and this is C. This is A, this is B and this is C. Can you answer this question? Can you answer this question? This is present on the ortho position, on the meta position, on the para position. Right? Okay. If we see BRHI, can you see any back bonding here? No, I can't see any back bonding here. So no back bonding. Can you see aromaticity? No. Can you see resonance? No. Can you see hyperconjugation? When we talk about carbanion, how can we talk about hyperconjugation? No hyperconjugation in case of carbanion. Only factor will be inductive, right? The factor here will be inductive effect, right? So as this is lone, as this oxygen has minus sign effect, because this oxygen OR, this is basically OR. So we know that OR has minus sign effect. This oxygen is electronegative. So it will take the electrons. It will also take away the electrons. It will also take away the electrons. The difference here is, it is closer, it has more distance, and this is more distance. So here the factor that is deciding the stability is the distance orientation of inductive effect, right? as this is taking away the electron, making it more stable. So this is the friend. The minus I group is friend of this carbanion. This is the friend. This is the someone who is taking care of you. This minus I group take care of this carbanion. So the friend should be closer to you, not far away from you. So more closer is the friend. If your friend is staying in your neighboring house, that is more happy. That makes you more happy as compared to your friend living in some other country, right? Okay. So this is living in some other country. This is just your neighbor. So your friend should be your neighbor, right? In that way, that makes you more happy. So this makes it more stable. So this is A, then B, then C, right? Okay. Distance is the deciding factor in this case. Which is the deciding factor? Distance of inductive effect is the deciding factor. For this, you need to know what are all the effects that are taking place here. Now answer this. This is A, this is B, and this is C. This is A, this is B, and this is C. What is the deciding factor in this case? No back bonding, ma'am. No aromaticity. No resonance, ma'am. No hyperconjugation, ma'am. We can only see inductive effect of this methyl group. But now, tell me if this is the hero or is methyl group hero or villain of your story. For this carbanion, methyl group is hero or villain. Everyone in the chat section. Is this a hero or a villain? Koshki, bacha, I don't have an idea about that. You can scroll the channel and you can go through that, okay? You can go through that, okay? I have not explored that much, right? Yes. So this is the villain. This is the villain. So this is, if the villain is like your neighbor, then it will make your life hell. So this will make it really unstable. And if the villain is far away from you, it is living in some other country, you don't care about that because that person is living far away from you. So this makes the stability order as C, then B, then A. Okay? C, then B, then A. Yes, anti-hero, right? So this is A and this is B. Now tell me, what is the deciding factor? Everyone, very, very important question. A very, very important question. Very important question. Mark this as important. By the way, all the questions that are on this display board are very, very important. Okay. So if you are watching this lecture, that is enough for you. For this particular topic, this lecture is enough. And I'm telling you, that's my promise to you. Okay. So this is A and this is B. So now this is negative. For negative, what we see, the order is BAR, HR. BAR, HR. Firstly, let us see, is there any back bonding here? Can you see any back bonding? If you have negative, you need to know if the adjacent atom has vacant d orbitals or not. And you know, fluorine and chlorine, among these, fluorine has vacant d orbitals. Fluorine has vacant d orbitals, okay? From inorganic chemistry, you all know that chlorine has vacant d orbitals, okay? When you understand, if you have ever done P block, this is the group 17, right? Okay, so we'll also cover P block also. So in that you will understand why this doesn't have why this has vacant d orbitals, right? Because of vacant d orbitals, it will donate its electrons to vacant d orbitals, and hence due to back bonding, A is more stable than B. A is more stable than B because chlorine has vacant d orbitals, right? Amongst the oxygen and sulfur, among oxygen and sulfur, sulfur has vacant d orbitals. Among nitrogen and phosphorus, phosphorus has vacant d orbitals. That means second member of every group has vacant d orbitals. That means second member of no. Here the factor of electronegativity will not be applied in this case. Okay, here the factor of electronegativity will not be applied, right? Will not be applied. But this will not be applied. The factor here is back bonding. The first case here is back bonding, right? For back bonding, the adjacent atom should have vacant d orbital. Fluorine doesn't have vacant d orbital, but this chlorine has vacant d orbitals, and that is the reason A is more stable than B. No, we have not applied electronegativity order here. Okay? Yes. The only trick here is knowing that which factor is applied here, right? Okay. So now this is A, this is B, and this is C. This is A, this is B, and this is C. Tell me, what is the factor that is we have applied here? What is the factor that we have applied here? Here also, you have this carbon. It has 1 sigma, 2 sigma bonds. So this is sp. It has 3 sigma bonds. So it is sp2. It has 4 sigma bonds. So it is sp3. Right? The minus I order is sp, then sp2, then sp3. Now, it has maximum efficiency of pulling the electrons. If something is negative and you're taking away the electrons, that means you are making it more stable. So that is why the order is A, then B, then C. This is the correct order. This is the correct order. The only thing that you need to know is everything in this world wants to get stable. If something is positive and you're taking away the electrons, so that is making it sad. And you are giving the electrons, that is making it happy. Right? That means it is making it stable. If something is negative, if we're talking about carbanion, and you are taking away the electrons, that is making it happy, because everything in this world wants to be neutral, and you have this negative and you are giving the electron, it is already very negative, you are giving the electron, it is making it very sad, very sad. If NTA has increased your syllabus, then you will be very sad. Now they have decreased your syllabus, so that is why you are very relaxed. Okay, the chemistry syllabus is now less. But now what about the difficulty level? What about the difficulty level? Because of that only, I am making you practice every single question that can be asked in your exam. Right? Okay? Oh my God, what happened to this watching? What happened here? What a blunder happened here. Oh my God. This will give me heart attack, I'll think I'll die someday. After seeing your watching, I'll die someday. The first time ever. The first time in my teaching life that I have seen this. Oh my God. This is so disappointing. This is very disappointing. Very heartbreaking. Okay. So this is A and this is B. No. Okay. It's okay. It's okay. It's okay, Diksha. It's okay. So now you have this A and this B. Now according to BARHI, what you will see, here you can't see any back bonding. Here you can't see any aromaticity. Ma'am, we can see aromaticity. PCC is applied here. You have 2 electrons here, 2 electrons here. So you have 4 electrons here. You have 4 pi electrons. So this is anti-aromatic. This is anti-aromatic, making it most unstable. Very unstable. And that is why this is more stable than B. A is more stable than B. Okay? A is more stable than B. Yes. I was about to teach you. No. Why are you saying B is more stable? Bacha, this is anti-aromatic. Anti-aromatic means this is most unstable. Out of aromatic, this aromatic, then non-aromatic, then anti-aromatic. And anti-aromatic is the most unstable species of organic chemistry. Like dancing resonance is the most stable. Right? Okay. Okay, you will cure my heart. You will be a cardiologist. Firstly, you will give me heart attack. Okay, then you will cure my problems, That's why I'm making you doctors. That's why I want my students to be doctors. Because after watching these kind of stuff, it's so heartbreaking, dude. This is very heartbreaking. Very heartbreaking. Okay, because doing so much hard work and seeing students not appreciating it, that's quite very disappointing. Okay, so now you have this A and B. As I told you, every second member of group, every second member of group has vacant d orbitals. So now you have this nitrogen and phosphorus. Phosphorus has vacant d orbitals. Phosphorus has vacant d orbitals, and that is the reason. That is the reason. If you see this, this negative will jump. This negative will give it minus the. Wait. This negative, because this negative, what will happen here? Just give me a minute, bacha. Just give me a minute. This negative, it will jump here, it will jump here. Right? So it will give negative charge on this and negative charge on this. That means this negative will give plus M effect. This will give plus M effect. And because of plus M effect, there will be negative charge on ortho and para position. There will be negative charge on ortho and para position because of plus M effect of this CH2 negative group, right? Okay. So now this is on para position you have negative, and on this para position you have negative. So now this phosphorus has vacant d orbitals. So that is why back bonding will take place here, and here there will be no back bonding. So that is why A is more stable than B. A is more stable than B. Okay, bacha. Okay. Okay, bacha. Understood. Understood. So perfect. It's perfect. Now you have this is A, this is B. This is A and this is B. Now tell me, what is the deciding factor here? What is the deciding factor here? Thank you, bacha. Thank you so much. Thank you. If you appreciate this, then do share this with your friends on your WhatsApp, on whatever things you use, and do also word of mouth, right? Also word of mouth. That will make me happy. Okay, that will make me happy. So I always make sure there is not even 1% question that is left in your particular topic. I always make sure that in less time I want to teach you more and more. So also you do your favor. Okay. Yes. So now this is A and this is B, and this also doesn't make me happy asking for all these things. I think that is your love for me that you should do, right? Okay. So I don't like asking these things, right? So do appreciate that. So this is but as you can see, the phenyl carbocation and the phenyl free radical are very unstable. So this is automatically very unstable as compared to this also. Here you have resonance. Okay. So A is more stable than B. Okay, G. There is a doubt. Is there every group there is vacant orbital in P block? Yes. In P block, yes. In P block, yes. Every second has vacant P orbital. Yes. And we have studied P block, right? So there we have studied that. It is only, I also teach you again also P block. So in that way, you will be able to understand why these all have vacant orbitals, right? Okay? Yes. Arre. Don't do this. Don't do this. Make a healthy competition, okay? Make a healthy competition. Right? Make a healthy competition. So this is A and this is B. So now you have BARHI, BARHI. No back bonding here, no aromaticity, no. There is resonance present here. There is resonance present here. And here there is no resonance. So that is why A is more stable than B. A is more stable than B. Okay, G? Okay? Yes. Perfect. A is more stable then B, CH3 group is present. Which case you are saying? The CH3 group is present, A is more stable. Yes, this is very unstable, right? This is very unstable. Phenyl carbocation or phenyl free radical is very unstable. So now this is A, this is B, and this is C. Tell me out of this which is more stable and which is less stable. Which is more stable, which is less stable. There is already very high competition. I don't want to create more. This is the case. Huh? No, don't do that. Huh? Don't do that. It makes me very sad. Okay, so this is A, this is B, and this is C. Now, as we can see, this is BARHI, this is BARHI. If we talk about back bonding, can we say back bonding anywhere? We can see back bonding here. We can see back bonding here. That means B is the most stable. Then if we compare A and C, out of A and C, what you will see? Out of A and C, what you will see? Out of A and C, what you will see? This has oxygen. That means this is more electronegative. It will pull the electrons. It doesn't have any oxygen, so there is no pulling of electrons, right? So A is more stable than C. So this is BAC. The order is BAC. Because of the minus side effect of this oxygen, it will pull the electron from a positive thing. Something is already electron deficient. You're pulling away the electrons. That means we were making it more unstable. So that is why C is the most unstable. And this is the most stable due to back bonding. So the order is BAC. The order is BAC. Okay? Okay, bacha. The order is B, then A, then C. Understood, everyone? Perfect. Very nice. Very, very nice. Just give me a minute, bacha. Just give me a minute. Okay, just a minute, just a minute, just a minute. Okay. So now next is this. And this is actually your homework. So this is A, this is B, this is C, this is D. Okay, that is your homework. This is also, I want, no, this is not your homework. This is just your homework. This is just your homework. This is not your homework. This is not your homework. Let us practice this. Let us practice this. So you have in A part, in B part, which is more stable. In both the cases, you can see the back bonding. Here the back bonding is with nitrogen and here the back bonding is with oxygen, right? As we know, this belongs to the same period. That's why we will see electronegativity. The electronegativity of oxygen is more than nitrogen. Oxygen is more electronegative as compared to nitrogen. That means, what does that mean? This oxygen means this will not be able to give the electrons as easily as nitrogen. So there will be more electron, the A will be more stable because of more back bonding in case of A as compared to B. Okay. The students have gone. They don't know. I still have lecture left. I still have lecture left. Okay. I still have. Okay. I still have a lecture left. Stability of intermediates that we have covered. We will cover acidic and basic strain today itself. Okay. Today itself we will cover acidic and basic strain. So all the students who have gone, I don't know why they have gone. What is the reason? Oh my God, this is a blunder that is happening here. Okay. So guys, join. Okay. So bacha, this is the Telegram channel. In this Telegram channel, what you will have, you have weekly schedule. All the classes, even you have daily schedule. Okay, will be given daily session PDFs, daily quizzes. There will be daily quizzes, weekly mock test from Sunday and Friday. There will be weekly mock test. All the links will be provided in the Telegram channel. And after that, we will analyze those tests as well. Then there will be weekly live sessions with the teachers. And there will be Super 6 series, right? The Super 6 series that is till now going on. All the updates about that is on the Telegram channel. So that will be in the description. You can just click it and join the Telegram channel. So everything here is totally for free. Everything here is totally for free. This weekly schedule, daily quizzes, daily session PDFs, weekly mock test. Everything here is totally free of cost. Okay, and what is this? This is the Telegram channel. As you can see, there's lots of knowledgeable things that are coming for you in the Telegram channel. Next is how to do PYQs. As you know, PYQs very important for NEET point of view. So how to give PYQ? Firstly, log in with your email ID, then click start test, and then attempt the test, end test. And also, then after that, we will get performance reports and the solution as well. Right? So these are the link will be provided in the description. Just click on that link, and it's a very simple step. Just write your email ID and start the test. Just a very simple thing. Okay. Now, how to give Telegram test? How to give Telegram test? Just click on the Telegram link quiz. Okay, the link will be provided to you. Click on that link, then start the quiz. Then uske baad you will write I am ready. And after that, score and rank will be provided to you. Among all the students, you can see where you stand. And also, after that, you can reattempt the test by try again. If you feel that, okay, I have not given this test, okay, there are so many mistakes, I want to retry the test, okay, then you can also reattempt the test. Understood, everyone? So everyone in the comment section, what you all need to do is just join the Telegram channel and all the links will be provided to you. Everything here is totally free of cost. Okay, no pennies charged here, no rupees is charged here. Everything here is totally free of cost. Understood, everyone? So are you ready for next? Bacha, are you ready or not? Everyone in the chat section, everyone, bacha, are you ready for acidic and basic strength? So this acidic and basic strength. So let me see just one thing. Let me just stop the questions. I just want to complete this today because there are lots of things that we need to focus on. Okay, we just not. I also want to cover the chapters of organic chemistry as fast as possible and in much detail. Okay, right. So, bacha, let us start the questions here. Okay. Okay. Yes. Acidic and basic strength. What is acidic and basic strength? Everyone in the chat section. What do you mean by acidic strength? Firstly, we'll focus on acidic strength. And I'll tell you just one thing more. That in the unit where you have nitrogen compounds, the questions are asked from basic strength. And we will cover that basic strength today itself. It's a very easy topic. Very easy. You will have a lot of fun while doing this topic. Okay, just stay engaged in this topic and do try to answer the questions. Okay, so now in acid, you have, what is the tendency of acid? Acid has a tendency to lose H positive ions, right? So you have an acid that is Ha. It has tendency to lose H positive ion and then give a conjugate base. This is acid. This is the negative ion is conjugate base, right? So if you have some money, right, and your friend is asking for that money, you will give that money only even if after giving that money you are unstable. So this acid will give H positive only if even after giving that H positive, this particular thing is stable, right? If this particular thing is stable. Why you all are preparing for NEET? Because this will give you more stability, right? So more is the stability of this A negative, right? You are giving your sukh, chain, everything. You are ruining your sleep, you are ruining your party sessions, everything. Why? Because you know that after giving up on all these things, what you will get this stability, the tag of a doctor. So this, the more stable is this A negative, the more stable is your position after giving so much hard work. The more will be the hard work, right? The more you will be able to work on your dream, right? So this is, if this is A negative is more stable, then this is a very good acid. That means it can give the H positive very easily. So if someone is asking you the stability order, what you just need to do? After donating the H positive ion, what is the stability of the conjugate base? Just see that, and that is the order of acidic strength, right? Okay. So now let us do the acidic strength questions directly proportional to the stability of ion. Okay. So now, okay. So these are the questions. And this is third, that is CH2, Cl, and this is COOH. Now, what is the answer? What is the answer? This is A, this is B, and this is C. What is the answer to this question? What is the answer? As you know, it has 3 minus I groups. Okay, it has 3 minus I groups. It has 2 minus I groups. It has 1 minus I groups. Okay, this is negative, positive, negative, positive, negative, positive. Right? So this is negative. So now what we need to do? Now this is negative. If you have minus I group attached to it, that means if you are taking away the electron from a negative carbon ion, if you are taking away the electron from something negative like carbon ion, it will make it more stable. More are the number of minus I groups, more is the stability. So order is A is B, then B, then C. The more is the order of stability of carbon ion, the more is the acidic strength. So acidic strength will be A, then B, then C. Okay, this will be the acidic strength. Clear to everyone? Right? Okay. So now next, let us see the next question. First, you have this phenol group. You have this phenol. You have phenol. Okay. Now, here you have an NO2 group. Here also you have one NO2 group. Here also you have nothing. And here you have CH3 group. Now tell me, what is the stability order? What is the stability order of this? What is the stability order of this particular? This is A, this is B, and this is C, and this is D. Right? What is the stability order? What is the stability order, bacha? What is the stability order, everyone here? As you all know, this is a phenol, this is negative, positive, this is negative, positive, negative, positive, negative, positive. So we will focus on the stability of this carbon ion, this conjugate base, this conjugate base, this conjugate base, right? What is the stability order of this carbon ion? Let us see. Let us see. It has, before this, write one thing here. Write one thing here and highlight this point. And highlight this point, that minus M, or you will say mesomeric or hyperconjugation is only applied on the ortho and para position. There is no mesomeric effect. As you know, when we are applying minus M or plus M, I've already drawn the structures of resonating structures. There we see that minus I effect gives ortho and para positive charge, and plus M group gives ortho and para negative charge. There is no charge on the meta position. That means mesomeric and hyperconjugation is also kind of resonance. That is a no bond resonance. So these two effects are not applied on the meta position. They are only applied on the ortho and para position. Okay. So now let us understand how to solve this question. This is the meta. This is the para position. So on the para position, this NO2 group, as this nitrogen is electronegative. So it will have minus I effect. And also, as this NO2 group has minus M effect and it is on the para position, so it will also have minus M effect. Right? It will also have minus M effect. And this one, as this is on the meta position, and on meta position there is no mesomeric or hyperconjugation effect. I think I need to drink some water. Okay, so there is no mesomeric effect, there is just minus I effect, no mesomeric effect on the meta position. Here we see no effect, this is simple phenol, and here we see plus I effect, right? Here we see plus I effect. Understood, everyone? So we all know negative, it is negative, and you have something that is minus, that is negative, that is electron withdrawing. And on the negative charge, if there are electron pulling effects, electron withdrawing groups attached to it, that will make it more stable. Something is electron rich, you are taking away the electrons, it will make it very happy. So there are two groups attached here. There is just one group. That means A is more stable than B. And here we see no effect, right? Then C. Then we have D. Now it is negative. You are giving the electrons. It is already negative. You are giving the electron. You are making it it's very difficult for this to gain the electrons because it is already electron rich. So we are making this very unstable. So this is very unstable. So the answer is A, B, C, D. Got it, everyone? Got it, everyone? This is A, then B, then C, then D. Everyone got it? Yes? Okay, perfect. So now let us see this. Let us see this. This is HF. Now this is also the question of inorganic. A very asked question of previous year. A very asked question from PYQs. A very asked question from PYQs. So this is A, this is B, this is C, this is D. How to define this, ma'am? How to define this? Okay. Now, as we know, this will lose H positive ion only when after H positive ion it is more stable. Right? It is more stable. So as you know, this fluorine, as you know, just wait. Yes, as you know, the order here is FON, then this is carbon, right? So this is very electronegative, then this, then this. This is the electronegativity order. This is the electronegativity order, right? This is the electronegativity order. That means in this HF, what you will see, the shared pair of electron is on the fluorine side. So this H positive is already lost. He is saying that okay, even I want this pizza. You and your friend has ordered pizza, and your friend is so clever like fluorine that it is eating that he or she is eating all the pizza. Now what will you say? I don't want to be friends with this guy. Okay, so what it does, it's like I don't want to be friend this person. I'm already over this person. He's eating all the pizza. I want this pizza. Okay, I am a very hungry person. I want this pizza. So now what will happen? There will be a this bond will break very easily, right? So this H positive will go very easily. So this is A, then B, then C. Right? More is the electronegativity, more will the holding capacity of electrons between that shared pair of covalent bond, and lesser will be the acidic, the more will be the acidic character, because this H positive, the holding capacity for making this H positive stay with itself will be very less. Right? The only reason is the electronegativity, as they are belonging in the same group, same period. Right? So this is the same period. I will write it as this is the same period. So we'll check out the factor of electronegativity. So now, if you are given the case, if you are given the case of Fm, HF, then HCl, then HBr, then you have HF. Here, they do not belong to the same group. They belong to the different groups, right? They belong to different groups. You have this fluorine, then bromine, then iodine, right? They belong to different groups. So what will happen here? What will be the scene here? What will be the case here? Now, down the group, you don't need to see the electronegativity here. Don't see the electronegativity in this case, right? The size here decreases. The size down the group increases, right? The size down the group increases. So this is HF, this is HCl, this is HBr, and this is HI. Now, for this HI, the bond length is maximum among these, right? Because the iodine has maximum size among these. Okay, down the group size is increasing, so HI has maximum bond length, so it has minimum bond strength, and minimum bond strength means H positive will be taken out very easily, and more will be the acidic strength. So the order is this. The acidic strength order is this. Okay. The acidic strength order is D. This is D, then C, then D, then A. Okay, this is the acidic strength order. This is not on the basis of electronegativity. This is on the basis of the bond strength. Now, let us do this question. Now, let us do this question. You have RCOH, and then you have this. And then you have this. Then you have this. Now, tell me, what is the order? What is the order? What is the order? Now, so many of you will say that, ma'am, this is negative, this is positive, negative, positive. Here, ma'am, we can see the resonance. Here, we cannot see the resonance, ma'am. Here, the resonance is throughout the ring, ma'am. Here only we can see the resonance like this, not complete resonance. Here we can see resonance like this. It has only two conjugating structures, two resonating structures. It has, ma'am, so many resonating structures, around 5 resonating structures here. Right? This is phenoxide ion, so you have around 5 resonating structures, and in this case you have just 2 resonating structures. And what is, ma'am? More the number of resonating structures, more is the stability. That means A will be less stable than B, isn't it? A should be less stable. But now I tell you, A is more stable than B. What is the reason behind that? The reason is the resonating structures of A are equivalent to each other. If you draw these resonating structures, the resonating structures are equivalent to each other. And equivalent resonating structures are more stable as compared to resonating structures that are not equivalent, and that is why I write it as equivalent. This is also mentioned in the NCERT in one of your paragraphs. So this is A is more stable than B, even though this has more number of resonating structure as compared to this. Because of equivalent structure, A is more stable than B. Understood, everyone? Okay, understood, everyone? Tell me, understood or not? Equivalent structures. Yes, I am not confusing you. I am making you learn so that you don't get puzzled in the paper. You don't take these things very lightly, okay? And we know that. We know everything, right? I don't want you to have that thing, right? That overconfidence. You should have confidence, but not overconfidence. Because there are so many things that I get to learn. Right? Okay? So now you have this. Now tell me, this is A, this is B, and this is C. What is the stability order here? What is the acidic order here? This is negative, positive, negative, positive, negative, positive. What is the acidic order? Here you have meta. This is on the para. This is meta, and this is on the ortho. What is the order? Let us apply Barhi. Let us apply Barhi. No back bonding is seen here. Okay, no back bonding is seen here. No back bonding is seen here. Right? Yes, ma'am. No back bonding. We cannot see any back bonding here. Right? Back bonding. Okay. Then we have aromaticity. Right? Okay? Yes. Then we have aromaticity. We can't see aromaticity here. Resonance, we can't see resonance here. It will give the electrons. So it will be plus M effect. So plus M effect will have negative here. Right? Here we can see, no. There will be no, as such, no. There will be no Barhi here. Yeah. Okay. So can't see any resonance here. Then about the hyperconjugation structure, no hyperconjugation structure in case of carbanion. Only inductive effect of this minus. This is minus I group. Okay. This is a minus I group. Okay. This is a minus I group. So what you all can see that this NO2 group present here. This NO2 group present here. This NO2 group will have on the meta, on the para position, it has minus I effect as well as minus M effect. Right. On the meta position, it has just minus I effect. And on the ortho position, it has minus I and minus M. Then how to differentiate between A and C? The differentiating factor here is the H bonding, the hydrogen bonding. The hydrogen bonding will make it the most stable structure among this. Okay, so C will be the most stable, and among A and B, A is more stable because it has two effects, that is minus I and minus M. So this is C, then we have A, then we have B. That means CAB is the correct order. Okay, CAB is the no ABC, no ABC, because C has hydrogen bonding, so this makes it the most stable structure among these. Okay, that makes it the most stable structure among this. Okay, Ji. Okay. No, so sorry. This structure is very stable. Wait. I'm so sorry. I'm so sorry. Yeah, this will make this whole structure as the most stable structure. This whole structure, if you talk about ortho-nitrophenol, is very stable because of this hydrogen bonding. But if you talk about the acidic character, now this hydrogen is strongly bonded to this oxygen. So that is why the hydrogen bonding is very strong. And acidic strength means the hydrogen, we need to lose that hydrogen, right? Acid is that which loses the H positive ion, right? But this is not able to lose H positive because this is already very stable. So this makes C very unstable. So this is C is very unstable, and among A and B, A is more stable than B. So yeah, this is ABC. Very correct. This is ABC. Yes. This is ABC. No. CAB is not. This is ABC. I was talking about the whole structure. Ortho-nitrophenol. If someone is asking you, see, there are two questions that are asked. Okay. First is ortho-nitrophenol. Ortho-nitrophenol is more stable than para-nitrophenol. Okay. This is a very asked question. That this is more stable than para-nitrophenol because of the hydrogen bonding. But if you talk about the acidic character, this is less acidic, right? Why this is the carbanion is less acidic? Because this whole compound is more stable. If HA is stable, understand this thing. If this is stable, then this will be very unstable. And this whole compound is very stable. That means A negative, the carbon ion will be very unstable, because this won't be able to lose its H positive ion, because this H positive ion is very this has hydrogen bonding with this NO2 group, right? So if this is stable, this is very unstable. As this whole compound is very stable, so that means this is very unstable. The carbon ion will not be formed. This will not lose its H positive ion. Okay? Very good. Perfect. Very nice. Kudos to Nancy. Very nice. So now, bacha, next let us do again. Let's do some structures. Okay, this is a very nice question. Okay, so now what is the name of this? What is the name of this structure that I have drawn? Everyone in the chat box, what is the name of this structure? What is, on phenol, you have NO2 group on the ortho and para position. What is the name of this structure? Bacha, what is the name of this structure? Tell me. What is the name of this structure? This is A and this is B. The structure is picric acid. Okay? Very nice, Mansi. Very good. Abhishek Rux. Where I have written stable? I have not written stable. Okay. Oh, so I'll write it as, yeah, this is the stability order of compound. Okay. So this is the picric acid. Now, this NO2 group is on the para position, so minus I and minus M effect. Here also you have minus I and minus M effect because it is on the ortho position. minus M and minus I effect. But in this case, you have, this is on the para position, so minus I and minus N effect. Here you have just minus I effect because no mesomeric effect on the meta position. Here also you have just minus I effect. So this means that here you have more electron withdrawing group as compared to more electron withdrawing effect as compared to this case. So A will be more stable as compared to A will be more stable as compared to B. Only the position of those groups will define which is more stable and which is not. Okay. So you need to know, ma'am, stable A is more stable. Am I right? Perfect. A is more stable because this has more electron withdrawing effect as compared to this B. Right? Okay. Yeah. Yeah. So I think yes. So this is also very nice question. Let us see who is able to answer this. Let us see who is able to answer this question. This is A and this is B. Right? Who is able to answer this? Tell me. You have one hydrogen group here, one hydrogen here, right? Which is more acidic? Which is more acidic? Okay? They will ask you like this. They will ask you question like this. The question will be asked like this, and you will be like, oh ma'am, this is totally out of syllabus. What to do, ma'am? How can we tell the acidic strength? Where is the hydrogen? How can we tell the acidic strength? The hydrogen, they are talking about this hydrogen because all the hydrogen are just very same. The CH2, CH2, CH2 group. But this hydrogen, this is, let us call this hydrogen number 1 and this is hydrogen number 2. This hydrogen and this hydrogen are attached to, this is attached to a carbon which is further attached to a sulfur. This is attached to a carbon which is further attached to a oxygen. So if this hydrogen is lost, if this structure is giving away this hydrogen, there will be a negative charge here, right? If this hydrogen is lost here, so what will be there? One negative charge will be here. One negative charge will be here. X positive will be lost, right? Okay. So negative charge here, right? So now what will happen? Now, as this sulfur has vacant d orbitals and oxygen do not have vacant p orbital. So here will be back bonding and here will be no back bonding, no back bonding, no back bonding. So this makes it more stable as compared to B. So this is more acidic as compared to B. Okay, this A is more acidic as compared to B. Hydrogen is playing hide and seek here. Hide and seek, yeah, hide and seek is playing, right? Okay, another very interesting question. Trust me on this. These are all the questions that are from so many books that I have collected for you. So I'm telling you, these all questions will strengthen up your concept. There will be concept clarity after solving all these questions, right? So this is a very important question, very mazedar, important, awesome, blockbuster question. Okay, all the concepts related to hydrogen bond, relating to acidic strength will be cleared after this question. Very, very, very important question. Okay, let us see. So they're asking this. If you need to answer, what is the order of H4? What is the order of acidic strength of this HA, this HB, and this HC? That means which H positive will be lost quickly among this A, B, and C? What is the order of H positive? Right? So let us see. If it is losing this HA positive, what will happen? What will be the structure? If it is losing this HA positive, the structure will be, here you have one OH. It has, oh, what happened to you, display board? What happened to you? Don't do this to us. Don't do this to us. Please let us complete our lecture. Only then You sleep only then. Only after that you can sleep. Not before that, right? This is OH only, right? This is O, right? This is O negative. Now, HA from this point have been lost, right? What will happen? This will be the structure after that. So now, what are the resonating structures that it has? This is negative, positive, and double bond. So this negative will jump here. This electron will go here, right? Either this can happen, either this can happen. This is the double bond here, right? And this is the OH here. This is double bond. This is O, and this is negative. This is OH, right? Okay. This is the resonating structure. This is the resonating structure. No other resonating structure is possible in this case. Can you see any resonating structure in this case? Can you see any other resonating structure in this case? Can you see? I can't see any other resonating structure in this case, right? Okay. So if it is losing HB, in this case it was losing HA. So if it is losing HB, if it is losing HB, if it is losing HB, let us see if it is losing HB. In that case, it has this double bond here. It has this OH here, this double bond here. This is O negative and this is OH, right? This will be the structure here, right? Otherwise, we will pour water on you. Okay, then if you are pouring water on this display board, it will die. Okay, it will die. Okay, so this is the structure. Let us draw the resonating structure. This is negative single bond, double bond. So this electron will jump here and this will jump here. So it will lead to a resonating structure. That is, this is the double bond. This is OH. This is negative. This is the double bond here, and this is the OH here, right? Okay, this is the resonating structure. Even now you have this negative single bond and double bond. So this is also another resonating structure. That is you'll have this O negative, this double bond, and this is OH, and this is double bond O, and this is OH. So now this particular has two resonating structures, right? Two resonating structures. If I write it very simply, this has three resonating structures, including this. It has just two resonating structures, right? Okay. So now, if we are taking away HC, that means it will have the double bond here, the OH here, double bond here, the OH here, and here you have, here only you have HC, right? So this will be O negative. This will be O negative. Now what will happen? Now there will be will there be any resonance? Everyone in the chat box, will there be any resonance present here? Will there be any resonance present here? This is negative, this is single bond, this is single bond. That means no resonance is present here. There is no resonance present here. Okay? No resonance. No resonance. If you're talking about apart from this structure, it has two resonating structure. Apart from this structure, it has two resonating structure. Apart from this structure, it has just one resonating structure. If I'm not including this structure, right? So that means HB is more easy to lose than HA. Then HC is the most difficult to lose because this is forming two resonating structures. This is forming one and this is forming no resonating structures. Right? Understood, everyone? Understood this concept? How you will do the questions like this? This is a question from MS Chauhan, a very important question. Okay? A very important question. After my lectures, you don't need to do, you don't need to refer to any reference book because I have already referred to those books and I have collected the best questions for you. Okay? The best questions for you that can be asked. So now, next question. Let us do the next question. Let's do some amazing question here. Okay, this is also nice. This is also very nice question. Okay. This is sulfur, right? This is sulfur and oxygen, right? And this is one part, both parts you have oxygen. Now tell me, which is more acidic? Which is more acidic? This is A, this is B, and this is C. Oh my God, what happened? I'm so sorry. I'm so sorry. What just happened here? Okay, that scared that actually scared me. Is there any mosquito or any rat or something here in this room who wants to study with you all? Anything here? Okay, now tell me. Now it has two hydrogen here, two hydrogen here, two hydrogen here, two hydrogen here. If we lose one hydrogen, only then we can calculate its acidic order, right? So what we will do, we'll just see after losing one hydrogen, what will happen? After losing one hydrogen, it will have a negative here, right? So let us see which is more stable. Now this is the carbanion. Sulfur has vacant d orbitals. Sulfur has vacant d orbitals. So these vacant d orbitals will lead to back bonding. Here we have two back bondings. Here we have two back bonding. Here we have just one back bonding, and here we have no back bonding. No back bonding. So in this case, A is more stable, then B, and then C. Understood, everyone? A is more stable, then B, then C. This is because of the vacant d orbitals of sulfur. As compared to oxygen, doesn't have vacant d orbitals. Sulfur have vacant d orbitals, and a carbon ion is electron rich. So it needs to give its electron to someone, to some atom. Only then it can give the back bonding. Right? Okay? Okay. Now, let them answer your next level question. They will just kill me, I guess, sometimes. I'm not scared of anything, but I'm very scared of small little mosquitoes and all these things. You know, that's why I was not able to take biology in 12th and 11th, because I was scared of all these things. But I know what you all are going to do. You all are going to cut part these the samples of the dead bodies. You are going to cut them and study them. You're going to do all those things. Even if I'm thinking about that, that is scaring me. You will do that in your I think in 11th and 12th also you study the samples of some dead animals, right? And even not animals, mosquitoes, right? Cockroach, yeah, you study the sample of cockroach, right? You do that. So that I was scared of them, and that's why I thought of not taking medical. That was my only thought in my mind while deciding between medical and non-medical, because I liked math and biology equivalent. But first thing is, for bio, I was very scared of the names and the most dangerous names in bio. It's very interesting when it comes to understanding those concepts that are going in our body, but when it comes to learning those names, I was hell scared of those things. And then second thing was the practical things in biology. Oh my god, very difficult. Very difficult. Cutting all those things and testing them. Tough task. Very tough task. Right? Are you all ready for that? You all are craving for that, isn't it? You are craving for that. You want that to happen, ma'am. We want that to happen with us as soon as possible. We want to be in a medical college and we want to study our body, right? About that all our part. Why scary? Oh, that's so sweet. That's why you are going to be the doctor, and that's why I'm not the doctor, because that thing scares me. Okay, if I'm not scared of those things, after that maybe you will see me. Maybe there was a chance that you might see me as a doctor or something, but because I was scared of this particular thing, I was scared of cockroach. That is why I'm not a doctor. That is why I was like, I don't want to be a doctor. How will I be, doing surgery and, doing all those things? It's actually, hats off to all the doctors. Hats off to all the doctors. It's very difficult, saving someone's life. And if you're not able to save them, there are some cases you're not able to save their life. Then calming yourself down, seeing all the, one of my friend, he's a doctor, and he says, when I visit hospital, there are so many depressing stories that I see in the hospital. And when I come home, and after that, making peace with my family is very tough, because when you are very sensitive, you need to see, okay, that's your professional life, that hurts you, but okay, fine, don't worry. I'll do my 100% and save those people, but I can't vanish. I can't just vanish all their sorrows, right? All I can do is, all these doctors can do is, they can try to save your life. So that sometimes gets very depressing. That's why I have that much respect. Because when any student asks me, I'm not feeling motivated, I'm thinking, you're preparing for something that is going to save someone's life. Okay, someone's life is in your hands, and if you're motivated to study for that, then what else do you need? For these common people, for us, the doctors are the god, because they save our life, right? Because whenever we feel low, we don't know where to go, we just go to this doctor, we trust them, right? We trust them unconditionally, we trust them, right? Totally blindly. Why? Because we know they'll save our life, right? So somebody's life is in your hands. You need to be very responsible for that, and you need to study very hard for that. I hope so. You all are very dedicated for all those things, right? Okay. Save somebody and save family. That is the gift of God, not scary, ma'am. Yeah, that's what I'm scaring. Doctor should be emotionally very strong. No, we are blessed to see you as a teacher only. Okay, perfect. Yeah, that's what I say. That it's a very tough job, and you all should stay motivated to study for that. Okay, it's a very tough job and the most noble profession, right? Okay, so this is A, this is B, this is C, and this is D, right? Okay, especially chemistry. Okay, thank you, Bacha, thank you. But I'm very happy being called a teacher. Very happy. Okay, yeah. This is my dream job. This is actually my dream job. My father and my mother is a teacher. They used to teach. Now they are retired. So that's in my genes, right? So this is A, this is B, this is C, this is D. This is a amide group, right? This is a amine group. This is a alcoholic group, and this is a carboxylic group. So let us understand this. Here, after losing H positive, in A case, you will have negative charge on nitrogen. Okay, you will have negative charge on nitrogen, as well as you will have resonance present here, as well as you will have resonance present here. In B case, you will have negative charge on the nitrogen, In C case, what you will have? Negative charge on the oxygen. And in D case, you will have negative charge on oxygen, as well as you will have resonance. So, what is the stability, right? What is the acidic strength of all these groups, right? In the A group, if you have negative charge on nitrogen, will it be more stable, or negative charge on oxygen? Negative charge on more electronegative atom is more stable. That is why D is more stable as compared to D is more stable as compared to A, because these two have resonance. So that is why I am taking A and D in the first place, and after that I'll compare between B and C. And here also B is more stable than C, so the order will be DACB. DACB. This is the order. Okay, this is the order. Yes. Perfect. After that, let us do the next question. Now, bacha, let us see one thing. This is the order. Let us see this order. Now tell me, what is the order? Is this the decreasing order, or this is the increasing order? Is this the decreasing order, or this is the increasing order? What is the right order of acidic strength? What is the right order? Is this the decreasing order or the increasing order? Is this the decreasing order or the increasing order? This is the decreasing order of acidic strength, right? Need to memorize this as it is. There are exceptions also involved in this. For example, this should be here, but it is now less stable. This is more acidic. Methanol is an exception. This is more acidic as compared to water. This is an exception. So that is why we need to memorize this acidic strength order. Okay? This is the first thing. This is the first thing. Before doing the question, one more thing. One more thing I'm writing here. Wait. Yes, I think yes. We are done with this. We have finished this. So now another concept is this is CH3, this is COOH, this is NaOH. This is a acid base reaction, right? CH3, COO, Na plus this is water. Always remember, if something is, if we have acid, if strong acid is converted into weak acid, then that reaction is feasible. The reaction is feasible only when strong acid is converted into weak acid. It is going in forward direction if strong acid is converted into weak acid. That particular reaction will take place very easily because this HA, this strong acid will easily lose H positive ion, and this weak acid will not be able to lose H positive ion. And that is why the reaction is feasible from strong acid to weak acid. If someone is asking you, if the question is being asked, will this be a forward reaction or a backward reaction? The answer is not from equilibrium. The answer is actually from GOC. This is the question of GOC, not equilibrium. Right? This is the question of GOC. Okay, previous question, one more please. Previous question, like this kind of question. We need justice. Okay, so this is acid, this is base, right? So tell me, is this a strong acid or this is a strong acid? Which is a strong acid? Is this a strong acid or this is a strong acid? Which is a strong acid? Which is more strong? Which is more strong? As you can see, this is more strong as compared to water. This is more strong as compared to water. So, this is a strong acid and this is a weak acid. This is the weak acid. And this reaction is proceeding from strong acid to weak acid. So, the reaction will be towards forward. So, this will be a forward reaction. This will be a forward reaction. The reaction will be forward. Understood everyone? The reaction will be forward. Okay? Okay, bacha? Okay? Perfect. Perfect. So now, next bacha we have, this is CH triple bond CH. Then you have NaOH. Then you have, iske baad, the reaction will happen here. This is CNA and this is H2O. Okay? Yeah. So which is more acidic? This water is more acidic or alkyne is more acidic? Always remember, H2 is more acidic as compared to alkyne. H2O is more acidic as compared to alkyne. Okay? As compared to alkyne, this is more acidic because, how can you say this, ma'am? How can you say this? This is more acidic. Okay? You know, out of this, alkane is more acidic, then alkene, then we have alkyne. And what is the reason behind this? What is the reason behind this study? What is the reason? Because for alkane, this is for alkene, this is for alkene, and this is for alkyne. This is for alkyne. Right? This is Sp, this is Sp2, and this is Sp3. Now this is more electronegative, so it is pulling the electrons. This is pulling the electrons. Wait. No. I have written the order incorrectly. Wait. This is minus I effect. So it has minus I effect. It is taking away the electrons. This is actually the order is this. Okay? Yeah. So the order is alkyne. Then you have alkane. Then you have alkene. Then you have alkane. Then you have alkene. This is the order of acidic state. But now here we have the comparison between water and alkyne, right? Between water and alkyne, water is more stronger, right? Between water and alkyne, water is more strong as compared to water is amphoteric. It is more stronger acid as compared to this. Okay, this is the weak acid and this is the strong acid. So here the reaction will be backward because the reaction proceeds from strong acid to weak acid. So reaction here will be backward. Okay? Yes. Okay. Now. Okay, let us do ortho effect. Okay? Let us do ortho effect. So this is, I am writing this ortho effect. So this says if you have a benzoic acid, no matter if you have a benzoic acid, no matter if a plus I or minus I, whatever group is attached to it, if that group is on the ortho position, that particular acid will be the most stable acid. Understood, everyone? If you have benzoic acid, no matter that group is acid or a base, no matter that group is minus I or plus I, if something is on the ortho position, whatever group, electron withdrawing, electron donating, the benzoic acid will be the most stable among this. This will be the most stable among this. We're talking about ABC. A is the most stable here. A is the most stable structure in this. Why? Because of ortho effect. That means in case of acids, in case of benzoic acid, at ortho position, whatever be the group, whether it's showing minus I effect or plus I effect, it will be the most acidic among all. Most acidic. Okay. So A is more stable. A is the most acidic. We don't see, we have not seen the plus I or minus I effect. I just wrote this is on the ortho position, so it is more stable, right? This is on the meta position and this is on the para position. So now let us understand. Because of meta it is minus I and because of para it is minus I and minus I, right? And this is negative, this is positive, this is negative, this is positive. Here the electron withdrawing effect is more as compared to B. So this will be A. After that, the answer will be A and then C and then we have B is the least stable among these. Understood, everyone? Understood? If you have benzoic acid, only then this effect is applied. Only then this effect is applied. Right? Now you have another question where you have benzoic acid, but in this case a group having plus I effect is on the different positions. A group having plus I effect is on the different positions. As I told you, you will apply the ortho effect on all the groups. Doesn't matter, even if this is plus I group, that doesn't matter to us. If this is on the ortho position, this is going to be the most stable, most acidic. Most stable, most acidic. Okay? Yes, in benzoic acid, everywhere this will be applied. If this is benzoic acid, okay? Yes. Okay, perfect. Now we have B and C. This is the meta position and this is the para position. On meta position, both the cases you will have minus I effect. It is also you have plus I effect and also you have plus I effect. Right? Both the position you have plus I effect. So now the CH3 has plus I effect. It will donate the electrons. Okay. The distance here is, this is negative, this is positive, this is negative, positive. So this is already a negative, this is carbon ion. You are giving the electrons through less distance, the distance is more here. So This is actually not in favor of stability of this carbon ion. That means it's the villain here. So more the distance of the villain, more happy, the more stable the carbon ion will be. So C will be more stable and then B. So answer is A, then C, then B. Okay? Answer is A, then C, then B. Right? Okay? Perfect. Understood everyone? Everyone in the chat section, have you understood this or not? Everyone in the chat section, have you understood this or not? After this, we are going to do as basic strength. Okay? After this, we are going to do basic strength. Let us jump to basic strength. Last topic of today's session. It will take 10 minutes, maybe 10 to 15 minutes. Right? Okay, everyone? Bacha, tell me, everyone in the chat section. Everyone in the chat section. Yes, I'm not able to see your comments. Okay, understood everyone? Now we are going to do the basic strength. The basic strength, okay? We are going to do basic strength. So, as you all know, basic strength is directly proportional to electron donating groups and inversely proportional to electron withdrawing. Okay. D for Diksha ma'am and D for basic. Basic means blue. Blue means good. Water is good for us. Right? So, basic Diksha ma'am. Diksha ma'am is positive basic. Right? So, basic strength is directly proportional to electron donating groups. Electron donating groups. Okay? So, now let us see some of the question and understand this with the help of some questions. Okay? Now, you have N that is attached to 3 methyl groups. Now you have one N that is attached to one CF3 and this is 2 methyl groups here, right? 2 methyl groups here and this nitrogen, this is attached to 2 these groups and 1 methyl. What is the order of basic strength? Now these questions will be asked in the exam from now organic compounds containing nitrogen also. Okay, these questions have been asked from that also. Understood everyone? Now can you please tell me what is the right answer to this? What is the right answer? Yes, I forgot to drink water. Yes. So thank you for reminding me. Okay, now tell me what is the answer. This is nitrogen. It has 3 groups that have plus side effect. This is having plus side effect. This fluorine is very electron negative, electron withdrawing. So this is minus side, this is plus side, right? This is minus side and this is plus side. More the number of electron donating groups, more is the basic strength. More the number of electron withdrawing, less will be the basic strength, right? So here we have 3 electron donating, 2 electron donating, 1 electron donating. 0 electron withdrawing, 1 electron withdrawing, 2 electron withdrawing. So that means A is more stable, then B, then C. The answer is A, then B, then B, then C. This is the basic strength. Okay, very nice, very good. Okay. Let us do other questions. What will be the order of this? What will be the basic strength order of this? What will be the basic strength order of this question? This is A, this is B, and this is C. What is the basic strength order of this question? Basic strength order of this question. Again, very simple. Basic strength is directly proportional to electron donating groups. Directly proportional to electron donating groups. Now you have, this is same, right? This is having H and this is H, right? Okay. It has no effect. It has no electron donating or withdrawing group here, right? We are considering this nitrogen. Okay, what does, okay, just tell me why I have written this like this. Basis means that accept H positive. If you have a lone pair, only when it is going to accept H positive, okay? Bases are which loses OH negative and accepts H positive, right? Okay? So, lone pair means this is going to accept H positive. And that is why we are going to focus on this lone pair present. Okay? So, now you have one group here, one atom here and one atom here. We know oxygen is more electronegative than nitrogen. This means oxygen is more electron withdrawing as compared to nitrogen. A will be the most stable because it doesn't have any electron donating, electron withdrawing. Oxygen and nitrogen both are electron withdrawing. Both are dangerous for these two, B and C. These two structures both are electron withdrawing, right? But this is more dangerous. And this is more electron negative as compared to nitrogen. As compared to nitrogen, this is more electronegative. So we will have A, then we'll have C, then B will be the least stable here. A, C, B. Okay, the answer is A, C and B. That is the correct answer. Okay, that is the correct answer. Okay, perfect. Now let us understand another concept of basic strength. Very important concept. So I already told you, if you have nitrogen that are localized, for example, you have one nitrogen that is localized. So this nitrogen, this is actually localized, okay? So another example is this. Now in these two cases, you have nitrogen pair, lone pair here also and here also, right? Okay. These lone pairs are not involved in the resonance. As you can see, the resonance is between these double bonds. Right? The resonance is between these double bonds. This lone pair is not involved in the resonance. That means lone pairs are localized. Lone pairs are localized here. They are localized. They are not going here and there. They are just sitting in one position. If your friend is sitting at one position and you're calling your friend, hey, I need your help, he's at his home only, you're like, okay, he's available for me, right? He's available for me. And this particular friend, you're asking, hey buddy, are you at home? And he's saying, okay, no, I'm at some party, I'm roaming around, I'm away with my family, or I'm going here and there, I'm at Bombay, I'm at Pune, blah blah, right? Okay, that means this particular lone pair, it is actually involved in the resonance here. That means this lone pair, these lone pairs are delocalized. These lone pair are delocalized. These lone pairs are delocalized. This is localized. This is delocalized. They are always available for your help and they are not available for your help, right? So always remember, if lone pairs are available, that means it is a good base. It is more basic as compared to delocalized. Okay, that means not available, not a good base. Okay, always remember, localized lone pair are more basic than delocalized. Lone pair. Always remember this. This particular concept will solve most of your questions. Most of your questions will be solved by this concept that localized lone pair is more stable, is more basic. Because if your friend is available, right, you will be there, you will go there. So now, this lone pair availability means the H positive will go there. It will be able to accept this H positive. If the friend is not available, where you will go? Nowhere, no? Your friend is not available, right? He is in delocalization state here and there, here moving here and there. So now these lone pairs are available. That means they will be more efficient in accepting the H positive. And more is the efficiency of accepting the H positive, more basic is the compound. Okay? Understood everyone? Is this concept clear to everyone? Is this concept clear to everyone? Everyone in the chat box, is this concept clear to all or not? So that we shall proceed next question. And this question is also a very important question that may be asked directly in your exam. Directly in your exams. This will be asked directly in your exam. Okay. So now let us see. This is A, this is B, and this is C. The level of questions that we are doing actually a very good level that will be asked in your exams, right? These will be asked in your exam. I am assuring you that. So now, bacha, as you can see, here we can see this is double bond, and double bond. These are the lone pairs. So this lone pair, this is lone pair, single bond, single bond. That means this is a localized. This is a localized lone pair. The lone pairs are localized. And in this case, lone pairs are also localized. In this case also, lone pairs are localized. And in this case, in the C part, this is lone pair, then you have single bond, then you have double bond. That means these lone pair will not be localized. Okay? These are delocalized lone pairs. Delocalized lone pairs. Right? So now, that means this will be least basic. Right? This will be least basic. Okay, ma'am, we have written it. What about A and B? What about A and B, ma'am? This is also localized. This is also localized. But do you know one thing? Do you know one thing? That this is sp3 and this is sp2. Now tell me, if you have sp, then sp2, then you have sp3. The minus I order is sp, then sp2, then sp3. This is the minus I order of the hybridization. Okay, about these three hybridization, this is the minus I effect order, right? Okay. Now we know basic strength is inversely proportional to minus I. Is inversely proportional to minus I. That means the basic strength order will be sp least, sp2, then we have sp3, then we have sp3. sp3 atom will be the most basic among all these because it has least minus I. Okay, basic is inversely proportional to electron withdrawing. Electron withdrawing means minus I effect. So this will be the least basic. sp will be least basic, right? So among sp3 and sp2, this is most basic. So answer is A, then B, then C. This is the correct answer. Okay. This is the correct answer here. Now, please, your lectures are add in slides by word written sentence. Yes, bacha, that I'll start from the lectures itself. Okay, from the chapters itself. Okay, I'll start that. Okay, don't worry about that. Because these questions don't require any PPTs as such, okay? But with hydrocarbons, we'll have proper notes, proper slides, because in that part you need that, okay? But in this part you don't need that, okay? Don't worry about that. That is in my mind. I have already started preparing for that. Okay, so now let us do this. Now tell me, which nitrogen atom, this is nitrogen number A, this is number A, and this is B. Which nitrogen atom is more basic? This one or this one? Which will accept? You'll be asked the question out of A and B, H positive will approach on A or B. H positive will approach on A or B. H positive will approach on A or B. Tell me, H positive will approach on A or B. A or B. A or B. Tell me. This is H positive. Will this approach on A? As you know, A has, in A, the lone pair are localized. The lone pair are localized, not involved in the resonance. And in this case, the lone pair are delocalized. In this case, the lone pair are delocalized. So localized, the availability of lone pair is more, so the basicity is more. So the A is H positive will approach on A faster than B. Okay. H positive will approach on A. Faster meaning not even faster. H positive will approach on A only. Okay. The availability of lone pair is more here. Right? Understood everyone? Any doubt till now? Any doubt till now? Any doubt till now? Any doubt, bacha? We are going to do the last concept. Ortho effect in case of basic. Ortho effect in case of basis that we are going to do. Okay? Ortho effect in case of basis. The ortho effect in case of basis that we are going to do. Right? Okay? Ortho effect in case of basis. Let us do that. In that case, I was talking about benzoic acid. And in this case, I am talking about aniline. If you are given aniline, if you are given aniline, aniline, let us draw 3 anilines here. Let us draw 3 anilines here. And any group, whether it's plus side, minus side, doesn't matter. Plus side, minus side, doesn't matter. Okay? I'm talking about a minus side. Okay, this is on ortho, para and meta. Now, let us see one thing. This is A, this is B, this is C. A will be most basic. What is the reason? Sorry, A will be the least basic. What is the reason? For ortho effect in case of basis, if a group is attached on the aniline at ortho position, that makes it least basic. In case of acidic, in case of acids, we were talking about most basic on the ortho position. Here we are talking about least basic. I think I am fumbling here. Most acidic in the ortho position, and here least basic in the ortho position. Okay? Least basic. Least basic is this one. So this will be, A will be the least basic. Why? Ortho effect makes it least basic. Least basic on the ortho position. Least basic on the ortho position. So you have this, this is the least basic, right? So this will be least basic. Among B and C, now B, on B we have minus I and minus M effect. On C we have minus I effect, that's it. More the electron withdrawing effect. More the electron withdrawing effect, basicity is inversely proportional to electron withdrawing effect. That means this has more electron withdrawing capacity as compared to C, right? So C will be more stable. Then you have B, then you have A. Everyone, is this clear to you? C, then B, then A. Here we are not talking about any carbon ion. We are talking about the acceptance of H positive, right? Accepting the H positive. No carbon ion is available here. No carbon ion, right? For basicity, it is inversely proportional to electron withdrawing groups. More is the electron withdrawing groups, more is the effect of electron withdrawing groups, less will be the basicity. So here the basicity is less. Okay, so this is C, then B, then we have A. Okay, C, then B, then A. Right? Okay, now last question of today's session. Last question of today's session. This is aniline. We have a CH3 here, ortho position. CH3 on the para position, and then we have a CH3 on the, and then we have a CH3 on the meta position, on the meta position. Now tell me which is most basic among these. Which is most basic among these? This is A, B, and this is C. This is A, this is B, this is C. Which is most basic? Now you know, at ortho position, no matter it is plus I, minus I, it doesn't matter. At ortho position, if it is aniline, we are checking the basicity, it will be least basic. So A will be the least basic. A will be the least basic. Right? So now B and C, we know it has plus I order, it has plus I effect, it has plus I effect. Plus I effect is distance oriented. More is the plus I effect, more is the electron donating, more will be the basicity. Now, the friend is closer to your house, so this will be more stable. So C is more stable. Then we have B, then we have A. Understood? Because the distance here is less, the effect of plus I will be more. Here the distance is more, the effect of plus I will be less. Right? And plus I is good group. It is an electron donating group. So it is a good group for checking the basicity. It is a friend of basicity. So the answer is C, then B, then A. Everyone in the comment section, till now any problem? Till now any problem, bacha? Any problem till now? Till now any problem? This is your homework. This is your homework. This is your homework. Okay? This is A and this is B. Right? Okay, everyone? Okay, everyone? This is A, this is B. Understood, everyone? Okay, perfect, perfect, perfect. Very nice. So please do your homework. This is the second question and the first question. And the first question is in between the slides. Everyone, please do your homework. Okay? If you're not doing your homework, then you are lagging behind many ranks. Okay? You're actually missing many ranks. Homework is must. And after that, solve your PYQs from GOC. In the next session, we are going to do a very important concept that will be asked. Rearrangement of... No. We are going to do isomerism, isn't it? Okay. After isomerism, we will do rearrangement of carbocation. Firstly, we will do isomerism, structural and stereo. Okay. Firstly, we will do structural and stereo isomerism. After that, we will do rearrangement of carbocation and all the intermediates. Okay? Okay, everyone? Clear? Perfect? Okay, very well. Okay then, bacha, do like, share and subscribe to the channel, and everyone do comment down because it makes me very happy if you do your homework and if you are appreciating. All we need is your appreciation. Nothing else that we are demanding from you, right? Everything here is free of cost. And also do check the description box and join the Telegram channel, right? Attend the quizzes. We'll start with a test analysis soon. And so many big surprises are coming for you this Saturday. We are launching something and something big is coming from you. Okay? So just wait and watch what is happening, right? Okay then, bye-bye. Take care. See you on Thursday. Same time, 5 p.m. See you all.